All right. Welcome everybody back. This is the third video today on September 30th, and I'm super excited about this topic because we haven't touched it yet. This is part of our technical video series on real-time rendering and XR. Um, so let's dive into things here. High-level reminder, generative landscapes is supposed to combine these three core pieces of technology together in order to achieve higher performing objectives, balance competing interests, and delight occupants. And we're using these techs for different reasons. And we are going to start talking about real-time rendering and extended reality today, to really start thinking about how we want to experience our designs and validate those designs in a real-time environment. And we'll go into this. This lecture or video, it's setting a conceptual foundation. Whenever I introduce technology, I don't want to introduce technology just for the sake of throwing tech at you. What I want to do is make sure that you are fully aware of how integral a piece of technology might really be to the profession. And so for that, this technical video is going to cover some technical elements, but it really is a conceptual foundation and overview and history. We're going to talk about a quick recap on what rendering is and why real-time rendering is changing the industry. We'll then talk a lot about the history and overview of XR. And laced throughout this will be this intrinsic value of what it can bring to landscape architecture. So the first topic is a quick recap on rendering. What actually is rendering? How was it done in the past and currently? And what is real-time rendering and how is it starting to change industries that would use visualization techniques like rendering? And why does all this matter to landscape architecture? So what exactly is rendering? We hear it a lot. We might talk about it a lot. People talk about rendering, that it's a design is nothing without a render, or you really need to render that. It gets conflated with words like money shot and collage. But I want you to become really precise when you think of rendering. Rendering's concepts, coming from etymology and application in computer graphics. What are the types of ingredients, pieces that go into rendering? How to calculate a scene from a GPU or a CPU to actually calculate this. And then everything after this is not really applicable because we're not going to use what's called pre-rendering as our method. We're going to use real-time rendering. But I laced a little bit of material in here just to show you uh, what it has been like in the past. So I'm not sure how many of you have watched Fight Club, but a famous line from that film is from Tyler Durden, who says, "To make soap, first we render fat." And originally, rendering was used when converting animal fat into something else. It was a process of purification and distillation. It still has that meaning, just in different context. It was then adopted in computer arts and graphics as it relates to the development of a scene using colored paints or pixels on a two-dimensional screen. And for us, it's the process of converting a 3D piece of geometry into a 2D image. It is a process, again, like distillation and development. It's just doing it by calculating light and material properties. So taking something blobby and messy like a 3D scene and compressing it into a 2D plane. So there's a number of different ways to render. These are two examples here of direct illumination, which just has a light, just, calculating the light as it falls through, in this case, a window to create these sharp lines. And there's other techniques that try to blend and blur that effect. And there's so many calculations and algorithms out there to create softer, more realistic, more intuitive feeling light. And as I mentioned, there's many. There's ray tracing, ray casting, radiosity, path tracing, and each of them has a different way to calculate rays of light in your model. Now, do you need to worry about this? Typically, I would say no, because there are bigger impacts on things like interiors that really matter more. Now, for some of you who are designing with, let's say, some roof elements and maybe some solar shades or canopies, maybe this does matter a little bit. What you need to know, and this is old, this is using V-Ray. Maybe some of you still use V-Ray. I'm not sure if that was ever taught. But if you are using V-Ray, it uses the technique called ray tracing, which basically is this. It is, here's my scene object, my geometry. I have my 2D plane of my, we'll call it a screen here. I have a camera that is set up behind that image screen or is producing part of that image because it's the bounds of what I can see. And I have a light source. So I have an object, I have a camera, which is constructing my image, and a light. And maybe I'll need some material properties. So there's like 4 kind of key ingredients here. And what's happening is that the light source is, first what's happening is that the camera is controlling what to see. And based on what it sees, it will then create an interaction with the light source. So it sounds a little less, let me go back here. It sounds a little less intuitive than it is, but it's an efficient way of calculating light on an object. Because if you imagine I have to calculate light everywhere, I'm doing a lot of extra work over here for no reason, because this is what I care about, my 2D image. And so V-Ray, with its process of ray tracing, these are the view rays that basically control what should and should not be calculated. It's simply just a matter of efficiency. Now, when it comes to rendering and real-time rendering, I want you to kind of pay attention here to the differences between this video game character. Pre-rendering, as it is sometimes called, versus real-time rendering creates different effects. Now, pre-rendering, because I'm focused on the 2D image and I can control the view rays going from the camera to the scene, I can get a lot more complex calculations to get this really nice, soft blurring effect. You're seeing here shadows in the creases of this woman's jacket. I'm getting much more detailed views of texture down here. I'm getting nicer shine on the actual clips of her jacket. Subtle details in the reflection of the goggles and its shadow. And you'll see in real-time rendering, I'm not getting that. And this is because real-time rendering does opposite of what ray tracing is doing. It's doing exactly what I said was not efficient. It's calculating light almost everywhere in a scene so that when I move my camera around this 3D character, um, it's not going to take forever to calculate. It's going to render it at the same quality and level. I can move this character, I can animate this character, I can move my camera, I can add in some simulation effects, and it's going to render it at the same quality and fast. If I tried to do that with the pre-render, it would take a long time because each frame of an animation or a series would need to be calculated. And that is the fundamental difference between what is now called pre-rendering and real-time rendering. So real-time rendering comes from primarily the video game industry. The video game industry requires this because you're always moving around in a video game. I'm not sure how many of you have were at the kind of onset of like Nintendo 64, for example, or PlayStation 1 or PlayStation 2, but moving your character with a controller through a 3D environment was kind of mind-blowing because you could experience that in a way that was not possible in the past. Yes, it didn't look hyper crisp or clear, or there wasn't a lot of shade and bounce of light, but um, it was pretty amazing. And over years, since I guess I don't know, Nintendo 64, PlayStation 1 is like 1998, 2000, maybe even earlier. 25 years of game engines doing this has advanced a lot. And now these images, the kind of real-time images, are getting closer to pre-render images. So if you are using V-Ray, maybe that's what you were taught. It is sometimes now called pre-rendering. It is a current and I fundamentally believe will be an older way that we render. And I wanted to talk more about this. There's a really good article, very soapboxy, but written from the perspective of a designer. And I'm just going to highlight a couple elements that I think resonate with me coming from a pre-rendering expertise and background, and then moving into real-time rendering. What is it? These are real-time rendering is essentially an animation or the production of an image or images in sequence that are rendered so quickly that it appears it's made in real time, meaning I don't have the lag of rendering it in V-Ray with what was called CPU or GPU buckets. It's happening within a time frame that is imperceptible to the human brain as being calculated. Behind the scenes, it requires an application stage, a geometry stage, and a rasterizing stage. I'm not going to go into the technicalities of that. But what I will say is that it has taken a relatively long time for design, landscape, architecture to adopt it. And the reason why that has not happened until maybe recently, and we're doing it in our class, is that, of course, there's a little bit of time and money that may turn some people off from adopting the new technology. Hopefully, you will get better at this. And if you ever had to bring that skill to an office, you would shave that amount of time and money down, which would make you an asset. But I really love this author's second point, which is, you know, historically, designers have really been all about control. I'm controlling the image. I'm making the money shot. I'm in control of what you see in the scene. And these static images, as mentioned here, offer this stranglehold on controllable inputs and outputs to perfect the representation of an idea for everyone. You are in control. You are coaching the audience through the scene from start to finish by just making this one 2D image, and usually it's static. So you can imagine, I really love this quote here. You can imagine the deer in headlights reaction that a designer has if you tell them that you have to relinquish control to make something a little more realistic or a little more interactive. It's scary because for the first time, your design will be judged with unprecedented accuracy before a shovel of dirt comes out of the ground. Now, again, I'm on the soapbox with this author here, so take this with a grain of salt, and I would love to talk with you all about this. But this author sees this as being a stepping stone to making design better. Why? The design process for at least Rob and I in this course is all about the continuous loop of trial and feedback, trial and feedback. I try something, I see what it's like. I try it, this is the experiment, going again and again. And good designers over time get better when they are getting feedback to inform them about what the next design trial should be like. So imagine at the onset of a project, you have an interactive environment that could be used by your design team to test ideas and ultimately get an experience of what that would feel like before it's built. This is pretty profound. And furthermore, as noted, the recent surge in virtual technology, virtual reality technology, which we'll talk about in a short while, takes this feedback loop a substantial step further. It has the potential to add layers of depth and output that would be at a one-to-one scale. What does the tree feel like? What does the hill feel like before it's actually made? Now, I do put the caveat, and I share the caveat with this author here, that despite all this possibility, there still is some hurdles to get over. Yes, there's budget. Honestly, I don't really share this opinion with this author because buying a license of V-Ray or Onscape or these other tools that were, well, Onscape is getting into real time and is real time rendering now, but other rendering tools like RenderMan or Arnold Render or a few others, they cost the same. The calculation cost and the development teams behind them is about the same. So they are coming at the same price now. It's just a matter of who's going to come with the skills to leverage these tools that are at the same price. And as noted by the author, there will be a tipping point when real-time rendering is used at the same time. And I think we are at that tipping point. Now, soapbox over. For those of you who are wondering what goes into a render, as mentioned in the V-Ray example, regardless of whether it's real-time or pre-render, you need a camera, a light, materials, and your geometry. And these are the things that you need all the time. Now, in the tools that we will be using, camera is already there. Lights will come pre-populated. Materials will come in a convenient palette. And the geometry is really what you bring to the table. So there are conveniences made in some of these real-time rendering packages. Now, real-time rendering tends to use a GPU. And we will talk about GPU and talk about why we are plugging our VR helmets and our screens into the GPU. And it's very specific. GPUs are also known as video cards, and they are used to primarily, as the name implies, graphics processing unit to calculate an image. Pre 2010, I would say, most rendering was done through your CPU, this is the central processing unit, the same device that calculates your genetic algorithm or calculates your OS. But honestly, now that video cards are becoming as powerful as they are, you don't really need to calculate it on another tool. And there's a really great example here of the difference between GPUs and CPUs. Hopefully this audio is coming through. Okay. Um, I just want to emphasize again, here is how a CPU is processing an image. The CPU takes input in and then it pushes something out one chunk at a time. This is what's happening with this happy face. It's spraying paintballs to make the happy face one chunk at a time. For those of you who have rendered using V-Ray using CPU, that's why you get buckets. That's exactly what's going on here. And when you paint, when you process an image using a GPU, you get all these little tiny processors, much lighter in power. They don't need all the intensity of a CPU. It's just processing a pixel, and it will produce it like super fast. And that is the difference, really, between a CPU and a GPU. Um, just some technical background here. Okay, let's go into our deck where we were. If you are still rendering using V-Ray, you may want to turn, this is side note, if you're using V-Ray, that is, you may want to turn on GPU acceleration. This can matter. And if you are rendering inside of Rhino with V-Ray, if you're designing things with NURBS, remember, behind every NURBS is usually a mesh and a render mesh. And like we talked about in other instances of meshes, it's mathematically impossible to render a NURB surface because you can infinitely continue to calculate points on the NURBS as opposed to a mesh. So again, if this matters, if you are rendering in V-Ray for Rhino, you may want to go to your document properties under mesh settings, and you may want to customize this to have a denser mesh so that you can produce better renders, essentially. Why does this matter to landscape architecture? Or where does this intersect with landscape architecture? I think I saw a few of you have this book on your desks. Innate Terrain. There is a chapter that I co-authored with Fadi Masood a few years ago, talking about the technology-driven shift in digital representation of landscape architecture. Kind of a mouthful. But during my introduction at the opening of this book, the launch at Daniels, I basically wanted to cover where digital representation came from in landscape architecture and where is it going. And you will notice here in the background that we are really honored to have Rob Wright in our class on this topic because he is like a founding, I don't know how to say, like a founder of this kind of thought process and application of how you can take digital representation of a landscape or how to take digital representations of models and make it useful for landscape architecture. So while I have a fledgling interpretation of that in my chapter, we should really be tapping into Rob's deep expertise and knowledge on this topic. That said, I have been doing some of my own thinking as it pertains to representation. I had the great honor of being invited to Unreal Engine's what was called Educator Accelerator last summer. And it was an invitation for a number of educators around the world to bring in a complex teaching topic that might be benefited by being exposed to some real-time rendering tools. And I was really interested in leveraging, in this case, Twinmotion. You can read more about how I experimented with it at the accelerator with this link. And it was specifically around generative design. It was over the years of seeing people use generative design is that they tend to look at a design from a top-down perspective or from a diagrammatic perspective, even if it's not generative design, but more especially in generative design. And I wanted to have versions, maybe my top 3, where somebody could walk inside of each of those top 3 generations, and they would get a little introduction, pavilion to each of these designs, where they would get a little diagram of what does the terrain look like, what was its performance value, and even a little QR code where somebody could, inside of the space, take a picture of it and fill out a form to vote on what they liked or disliked about the design itself. So it was a method of sharing it with my stakeholders. This was a means in which to share it with stakeholders and basically really get at interactivity with those stakeholders in mind. So let's do a pivot. Let's talk about let's talk about XR. What is XR? What does it mean? How is it being used outside of games? Because I think all of you might think when you see a VR headset, this is a video game. How is it being applied to architecture, AEC? And again, the underlying thread here is that it does have value to landscape architecture. Let's recall this real-time rendering rant that it's the virtual reality technology that takes the feedback loop of design and iterate forward by making it feel more immersive. So what is XR and why are we talking about this now? First off, you're probably like, what is XR? Why is he introducing a new acronym that I am not used to? In the same way that Lord of the Rings has one ring to rule all the rings of Middle-earth, the XR is one term to rule them all. There are a number of different acronyms and types of things that relate to reality. There's augmented virtuality, AR, MR, VR, XR, SR. There's so many. And you just need to think of XR as this extended reality umbrella term. Under it covers augmented reality, like wearing little headsets and seeing things, VR to imagine what might be going on, and mixed reality to actually have some objects like your hands or tables or objects that will interact with a virtual projection. Now, you're probably wondering, how does that actually translate from that little comic-y graphic into something that I can understand better? So I'm going to compare RR, real reality, that you would experience with your eyes and hands, and this kind of living room scene. Augmented reality purely lays over the real world with some type of a digital enhancement or image. So keep in mind this little living room scene. I'm just laying over this 3D robot character. Notice how, I can see through the couch. There isn't much real interactivity with the couch. It's on top of it. It's just laid over. That's augmented reality. Mixed reality, which is becoming all the rage right now, is where the real and the virtual are overlaced and intertwined. There is a method of wearing a particular headset that's pushing an image to your eye that will take into account an object in real life and an object in virtual and will conflate those so that in this case, the little robot looks like he's behind the couch. There is a little sidestep in here called augmented virtuality. I'm not going to cover it. It's getting dropped in many instances. But we are all maybe more familiar with virtual reality, which is a completely digital environment. I don't care about the living room. I want to see the robot in his world. Now, all of this together is what we call the reality virtuality continuum. It is basically going from real life to completely immersive. And anything that falls from VR to AR is under that umbrella term of XR, just extended reality. I'm extending what I can see in real life with all these different flavors. So as a quick kind of test, I don't know how many of you have played Pokemon Go. What version of XR is this? I don't know how many of you play Creed, Rise to Glory, but what version of XR is this? And I'm sure many of you have watched Marvel's Iron Man or something of the sort, but this is another version of XR. Okay, why are we talking about XR now, today, in our current time? Basically, we're talking about it now because the reality virtuality continuum, again, here is extended reality fitting augmented virtuality and VR itself, originally was scouted out in the 90s by this guy named Paul Milgram, a mechanical engineer, but is Canadian. There's a really rich history of Canada and things related to graphics and graphic processing, including VR. But we're talking about it today because there's this rich history of immersive media that has come into what we have today with our XR tools. And it starts for me at least anyway, when I'm doing some historical lessons in this, of what does it mean to bring someone into immersive media? I mean, I guess we could go back to like cave paintings here. You know, the French caves where they had paintings and the flickering of fire would make things seem more immersive. But in a more contemporary history, we can go back to the 1800s with what was called panoramic paintings or cycloramas. And these are paintings that were meant to be intentionally immersive, where these super large paintings would even be wrapped around a building, the inside, 360 degrees, and were called cycloramas because you would walk around them and you would be inside the landscape. Many of them were landscape images or battle scenes of some kind. And there was a really famous building called the Rotunda in Leicester Square, in which one of these very famous panoramas was exhibited. In the 1820s, we get this introduction of stereoscopic imagery. Stereo, Greek word for solid, and scopic for vision, the impression of a solid image, or the idea that you could almost touch what it is that you're seeing. Originally developed in the UK under Sir Charles Wheatstone in the 1820s, had this idea that you have a left and a right eye that give you a sense of depth perception. And by slightly keeping them off one another, your eyes would simulate a sense of solidity or the ability to bend around an object. And there were these stereoscopic devices in the 1820s, like you're seeing here on the left. And then there was even this larger thing that you could put together that arrayed it for more like demonstration exhibition purposes, the Kaiser panorama on the right. I don't know how many of you have played with this, but you know, the 3D ViewMaster is exactly the same technology. It's a slightly askewed left and right image that makes you, that tricks your brain into thinking that it's more 3D than it is. In the 1950s, evolving here, we get this concept of this arcade style cabinet that would simulate numerous senses like acoustics and fans and smells and even a vibrating chair. In the 1960s, Ivan Sutherland basically could be credited actually with coming up with the first VR head-mounted display called the Sword of Damocles that was connected directly to a computer and is not based on camera. It's just feeding CAD information directly into the display. And then the video games start. The 1990s was probably the first explosion of this. We see Nintendo's Virtual Boy, Sega Genesis VR, arcades get into this. This was my first exposure to VR as a kid, playing with these different techniques. And it was low fidelity, it was low resolution, it was only in red and black. The stereoscopicness was okay, but it was pretty neat to feel like you were in a game as opposed to just seeing a game. And then there was this explosion in the 2010s where this small startup called Oculus was able to do some extremely lightweightness of the stuff you see here. This was very heavy and very big and very low fidelity. And they were able to take innovations in silicon graphics, silicon-based graphics, chips in other words, and compress it into something very small. And it was really built on ideas that were already being experimented by Google when they had this concept called Google Cardboard, which was to take all the processing power inside of your phone and use that as a means to simulate 3D. Of course, there are a couple of other milestones to note here, but there's a fantastic website called Virtual Reality History where some of this is pulled from, and some of it I added myself. So again, why are we talking about XR now? XR is going to continue to explode the global market value. It maybe hit one of its peak hypes trend maybe a few years ago during the pandemic when everybody was bored at home and people really wanted to see things and entertain themselves in new ways. And that became this false signal in the market. But still, it has a continuing trend. This is now done here, this article on the left, where a fifth of Facebook employees are working on VR and AR. AI has effectively shifted that. And the metaverse was all the rage a few years ago, and that has calmed down. But there are some real drivers here to why we are seeing things. There is a network of people using it. The data is becoming more compartmentalized, and consumers are able to afford it and to buy it, and there's appetite. The trend is that these tools are becoming more lightweight and more mobile. You can even use mobile devices to do it. And the data requirements to pull data from an untethered device is getting better. And we are reaching this inflection point, as noted in the article earlier, where industry is starting to adopt it, people are demanding it, and coronavirus was a major push into basically getting us more and more devices. I think I heard quite a few of you say that you bought devices during the pandemic. Well, this is pushing it now into industry readiness. It has a much bigger implication in the background, which is this data interface. We used to interface with computers with command lines. Then there was a GUI, the Windows that we're kind of used to in the 80s. Touch became all the rage in the mid 2000s. And now we're in this spatial computing. And Jeff Bezos marks here, AI is the golden new era. I think that's very true. But VR and AR will allow us to interact with that technology in ways that doing it on a screen just isn't worth it anymore. The accessible hardware, VR and mixed reality used to be done in things called caves, computer assisted virtual environments. They were big, really big. They required a lot of processing power, 4 or 5 workstations to project onto all these different surfaces. And it was limited to one person at a time, and they were expensive, $1 million plus. Tethered solutions, the older units that used to be on your VR carts, started to break that, where it needed a little less space. It's still limited to one headset, one workstation. You needed a computer, and it was one person at a time. It was around $4,000. Some of the Vive Pros downstairs are worth that. And then came Oculus going to the next level with these untethered solutions, these lightweight things. You can sit down, you can stand up, you need less than 8 square feet. You can have one headset, and now there's people that can join in one session at once. You don't need any workstations. And it's like $400. So much so has these changes changed a way that technology is being adopted, that industry is now having some dedicated XR divisions. I've chatted with Adam Chernick a number of times, the gentleman that you see here. He is basically leading this division within of shop architects. And many of these offices, Zaha Hadid, Skanska, Takanaka, Gensler, many offices have dedicated XR divisions now. So how is this impacting architecture, design, engineering, etc.? Keep this in mind that VR tends to be used more in the design stage, the pre-construction phase, and then augmented reality, like this company here, XYZ Reality, tends to be used more on site to actually execute something. And so you can think of this continuum broken down into 6 steps. There's designing in XR, maybe a more natural space to sculpt and to pull and to shape things with your hands. You can collaborate in design in XR. You can engage with your clients in a new way. You can coordinate some design and build. You can even assist assembly of complex parts on site. Or in the future, you may even be able to manage physical assets. Think about a wind turbine here in the background, and you want to see how is that wind turbine working when I get to site? What are the guts of that turbine when it's working? This could be a way of doing that. I'm not going to go into all these phases here, but I leave the slides for you. So how are we accessing, as design professionals, extended reality? Some people are using the real time and game engines. They're using Unity, they're using Unreal Engine, and there's other ones that are around these game engines. And then there are some what I'll call XR ready apps that might have these in the background, but are making it much more simple. And we are using one of those. We are using Twinmotion. And Onscape, you guys have probably used Onscape in the past, is similar. It's a real-time rendering app that is using a game engine. I believe Onscape is using maybe a flavor of their own, but Twinmotion is using Unreal. And now people are really using it. Here's a during the pandemic, Canon Design. I'm not sure if you're familiar with. They're a vertically integrated office that does landscape, building design, engineering. They started using a software called Archeo, some Oculus Quests, and Revit to do a design review. No one could meet in person, so they did a weekly design review. They mocked up boards, and they had people commenting on the boards and then jumping into the designs itself. A great case is in healthcare design. Instead of designing a hospital, basically ward and mocking it up, design professionals and healthcare professionals could review a space in VR and say if it was good or bad before going into construction. Some other examples here more on the engineering side. I won't really go into too much detail. And things like construction management, being able to assemble complex pieces. This is, I loved working with this Japanese customer called Takanaka. They were really interested in combining extended reality by way of the Microsoft HoloLens to teach construction workers of the future how to work with increased complexity. Another side view or another side perspective. This is a project I worked on a few years ago during the pandemic. There was this fantastic project called Obsidian, which was imagining livings and dwellings for Black families in the US. And you can follow that link here if you want to see it. It's by the Black Artist Designers Guild. It's the house design. They have other projects. It's really about how they wanted to build a real house that would reflect Black values in America. But because of the pandemic and budget changes, they could only build a virtual one. And they consulted with Autodesk to help them build a virtual house. And we did this on a website. I believe it should be VR ready now, but the intent was that people could actually go into this house and experience it. And of course, there's now all of a sudden like design competitions only about virtual designs. The Bee Breeders annual competition had one specifically for this. And there is the concept of architects moving solely into virtual, and that's growing interest. So there's one example here of an architecture firm that is making way more money designing real estate projects in the metaverse than they ever did in real life. And this is broadening how designers can make money in the future. And designers who are XR ready will be a little more future proof. You will be more competitive in the marketplace by knowing some of this and knowing how to tie it into that design feedback loop. So I hope this gives you some conceptual underpinnings behind real-time rendering and XR. And the work we'll be doing with Twin Motion hopefully is now a little more established. Thank you.